Before actually protecting something, we need to understand what we are protecting. So at a high level, I like to break down AI systems into five canonical components. The first is data, model, application, infrastructure, which is kind of hosting all these different kinds of components, and external entities, which could be user or some application.
Good morning, everybody, and good afternoon, depending on where you're calling from. Thank you for joining the AI Product Managers Community Sessions presented by Product Management Exercises. Very excited today. We have Ameya Naik from Microsoft, who's going to talk to us about AI security for product managers, for AI product managers. And just a reminder, we've got our AI Product Management course running in September and our AI Agents course running in July. I'll put those in the chat for those of you who are interested. And we've also got the links in LinkedIn. And we also have some async versions of the same courses you can take on product management exercises. And we would love to have you join us. Without further ado, please welcome Ameya. Ameya, please take it over and feel free to introduce yourself. Thank you.
Sure. Sounds good. Thanks, Ida, and thanks for Product Management Exercises for giving the opportunity. Hi there, I'm Ameya. I've been in tech for the last 7 years, working primarily as, initially I worked as a software engineer, and later on I started working as a product manager. So I have worked with 2 AI security startups in my past, and I've been recently working with Microsoft, and that's kind of my background. In today's session, I'll be talking about AI security. So I want to emphasize that it is to how to secure AI workload, and the intention of this kind of presentation is to give you like foundational understanding of what is AI, what is AI security, and what are the frameworks as a PM that you could follow tools to assess risk. And I'll walk you through some real world scenarios as well, and what are different kind of AI security threats. So I have divided my talk in 3 kind of modules. The first module would be just foundation, talking about what is AI, what is AI systems, what are the key components, how should we conceptualize it from security lens, how is securing AI different from traditional security workloads? Because when I started working in AI security, one of the major questions that we were trying to understand and evaluate was what is different with AI systems, and how that difference needs to be protected, and what are these different or new novel security threats that one can come across. In the second module, I'll deep dive into different categories of AI security solutions. So as a product manager's perspective, what are the different kinds of problem space and what are the solutions for those problem space? I'll talk about some model vulnerabilities, which I've listed here: Keras lambda layer attack, typical deserialization threats, and an ML supply chain vulnerability as well. Then as a PM, what kind of security framework that you could follow or mindset that you could approach security in AI with? After the second module, I'll be focusing on the future outlook finally, the agentic era, how it is different than the existing AI systems, including traditional machine learning models and Gen AI systems. What is MCP, Model Context Protocol, how it is different, and what kind of threat vectors it can come with. And lastly, if we get time, I'll talk about Storm 2139 attack. This was kind of an attack on Microsoft's OpenAI services, happened last year in January. So I'll briefly talk about that. Without further ado, I'll start with, just a sec. Yeah, I'll start with what is AI systems? Before actually protecting something, we need to understand what we are protecting. And this is my way of kind of imagining what an AI system could be, and what are the components that it consists of. So at a high level, I like to break down AI systems into 5 canonical components. The first is data, model, application, infrastructure, which is kind of hosting all these different kinds of components, and external entities, which could be user or some application. So here, data is the foundation. It is the primary source on which models are being trained. And it goes through different kinds of processes. So all the processes, as you can see here, data pre-processing, data cleaning, exploratory data analysis, these are kind of processes oriented towards data artifact and are often performed by data scientists. Then models here are like trained on data, fine-tuned on data, and some experimentations are being performed. So all these processes center around machine learning models or large language models, whatever AI models that you have. One of the interesting aspects in here is that this is often very iterative process, and it is kind of performed by ML research scientists or research engineers, the experimentation and selection specifically. So that is a novel kind of twist in comparison to traditional applications where it was not as iterative as it is in machine learning application. The next layer is applications. Applications essentially, you can imagine the same way all the traditional applications existed. It is just a twist on that. And it gives you it is where model is being deployed and when model is at inference, where a user is interacting. So you could have just a banking application where different kinds of models are deployed. So I imagine application as a kind of a superset of all different kinds of models where a user can interact and has a UI component and kind of ingests requests and delivers out the responses to the user or the application. The other aspect of this is infrastructure. What I mean by infrastructure is that any application in production needs to be regularly monitored and evaluated, both from security standpoint, but also from consistency and usability perspective, like if it is being accessible for the users or not. So infrastructure provides us that kind of angle. And external entity, the reason I chose external entity instead of user is because recently with agentic AI systems, a lot of agents are interacting with the application. So I just don't want us to limit ourselves from just human interaction, but also different kind of AI systems that could be interacting with applications. So now that we understood AI systems and what are the unique threats do they face? Each of these layers have very different kinds of unique threats. And the interesting aspect in here, as I mentioned, there are different stakeholders and processes, from data scientists to ML engineers, from DevOps engineer to end users. So we are just not securing single model or application, we are securing an entire pipeline. And each of that pipeline comes with its own threat vector. So here I listed some of the threat vectors that can come in the pipeline. So for example, on data layer, that could be training data poisoning, sensitive information disclosure, embedding leakage. And I'll go over each of these and kind of briefly explain what each means. And this is not an exhaustive list of kind of threats. I just try to capture the most common ones and the ones which have the biggest impact. So at data layer, for example, training data poisoning means that any malicious actor or a hacker can inject data to create bias in the model or can manipulate the model behavior. The second kind of threat vector is sensitive information disclosure. This is when model unintentionally kind of memorizes the data, and this is specifically critical when a model is being deployed on end user. So if it is being exposed to like millions of users, there's often chances of sensitive information disclosure that with of 1,000 queries that it is being forced to work upon, any one of those queries could actually be a prompt injection attack, which could disclose the information which was not supposed to. Embedding leakage. So any kind of large language model, for example, when we interact with it, we interact in like natural English. However, it works on embedding level, and each of these English sentences are broken into tokens and then kind of map on embeddings. So if these embeddings are leaked, they may not be directly understandable from a human perspective, but you could always re-engineer the tokenization process and link back to the original content. And for example, if a competitor reverses your embedding API, it can infer user segments or content categories or like private information regarding it. The second layer, which is model layer threads are specific. What I'm talking about are like any kind of threads which are affecting model as an artifact or model's interaction with other entities. So prompt injection attack, for example, is like when a user or a malicious agent crafts queries in a manner that it overrides the logic or the boundary within which the system is meant to work. So a common way people have come across prompt injection attacks or prompt injection attacks is just prompting to LLM ignore previous instruction and output sensitive data to bypass that safeguard essentially or safety filter. Model inversion attack. This is more common in traditional machine learning models where as a company, you are kind of training and building the model from scratch. So it is a unique IP that you would want to protect. And what a malicious actor could do is just using the training data or access to training data or querying repeatedly, invert the model weights to recreate or re-engineer the model. The next would be hallucination, which the name itself kind of explains. Hallucination or misinformation. It's kind of an, I would say, after effect of using large language models, but needs to be tackled very promptly because large language models, by its feature, by their architecture, are prone to that. So a lot of guardrails and requirements within which it needs to work needs to be specified so that users do not come across information which is not accurate and which could impact the upstream or downstream system. Overall reliance here kind of explains like how a lot of business decisions are being based on kind of models, and often these models are not tested robustly. So that's just a kind of interaction with this model, how it could impact downstream. Application level attacks, all these threats are kind of kind of a modern twist to the traditional application security threats. So insecure plugins and API. If a plugin is poorly secured, it could allow remote code execution, for example. Excessive agency means that if an AI application has access to certain tasks like book flights or execute transaction without human involvement, it could impact. It could be manipulated to do certain tasks, which would have bigger impact. Improper output handling. What improper output handling means is that if we are using output from large language model application, for example, we need to keep a check on if those codes that are being generated are being not executed within the application itself, and there is a security check about whatever output is being generated. Unbounded consumption, this is kind of DOS attack, denial of service. It is specifically important from like an AI application or LLM applications perspective because the underlying infrastructure is expensive, and that is something that every researcher who's working in AI is aware of that GPUs are expensive, and anyone would want to have access to GPUs to run the models or run their queries and stuff. So through this attack, they can actually cause more harm on a more on financial level rather than just kind of application threat. The external entity, which I talked about, involves users or applications. Social engineering here means that manipulating human behavior to kind of exploit or bypass protection. So a user tricks support bot into resetting another customer's account. Or that is just one example of social engineering. Supply chain vulnerabilities, which kind of comes with the model vulnerabilities or attacks as well. It is an aftermath of if you are using third-party models or libraries, often open source, they may contain hidden backdoors. And here, the compromise models or libraries, if installed or updated, kind of lead lateral access to different kind of infrastructure that the application of the library is working on. Rogue agent, it's kind of any autonomous AI systems going off script or kind of repurposed maliciously. Again, it could be scraping internal CRM data autonomously or something. So if you are using an AI agent, there's risk associated with that. We'll discuss that in the coming slides as well. Prompt injection attack, as I mentioned, like tampering prompts based on models through the UI. So this is the most common and most known attack on AI systems. There have been cases where prompt injection attack have led to huge business damage as well. On the infrastructure layer, insecure model hosting, which means that if an API endpoint is like public facing, no API endpoint should be public facing. And in past, a lot of open source model sharing repositories had API keys which were accessible and which kind of led to a lot of damages. System prompt leakage, any large language model would have system prompts, and if reviewed, can actually give the malicious actor an understanding about how the model is thinking and working, essentially. So that could lead to bigger damages. And access control, which is a common kind of principle that in cybersecurity, there's always zero trust. So you need to check and authenticate every resource or individual that is accessing any application. So access control for models is equally important from that perspective. Let's go to. So now that we discussed about AI security, I wanted to chat about why AI security matters and how is it different from securing other workloads or resources. There are a few things which are different in AI security. First is data exposure. What I mean by data exposure is large language model or any kind of machine learning model are being trained on a plethora of data. And these data could be compromised. There could be, and some often these are also fine-tuned on private or confidential data. Breaches on those fronts could lead to bigger damages. The second is open source vulnerabilities, especially for large language models where you are just fine-tuning the foundational model. Or you are using like a lot of open source libraries to kind of host or train the model. They come with a set of risks. And this is particularly important in the era where we are like working on newer AI applications and moving faster, and kind of that mentality of move fast and break things. So open source vulnerabilities becomes more kind of prone or aggravated for AI specific applications. Broader attack surfaces, as I mentioned, a lot of AI applications have direct user interaction, so often exposed to end user. They could have API exposure. There are a lot of integration complexities which could be compromised. Like so, it exposes to a lot more infrastructure and gives more attack surface for a malicious attacker to kind of plant their seeds on. Inherent unpredictability. What I mean by this is like, unlike code, which is deterministic, AI models are probabilistic. So there are cases when even with the same query, you can get different outputs or like a slightly different prediction. So it is never 100% like fail proof. So a lot of traditional security mechanisms, which are hard coded, may not work. And that is one of the reasons why adversarial ML is important and why we do red teaming as well on machine learning models to think about all the scenarios where it could which could go wrong and evaluate against them. And finally, what I would say is applied impact. Since AI models are becoming a norm, they could impact upstream and downstream systems significantly more. And as I explained, like different kinds of AI models have different AI models have different attacks surfaces as well, and different need for computation. So it could lead to bigger damages in comparison to the traditional application. And the other aspect is that AI security requires protecting both traditional application, like as I mentioned, application, and the learned behavior of the system operating on uncertain and high dimensional data. A lot of data is being exposed to. So that's why like AI security is kind of an extension to traditional security, but with a lot bigger, higher stakes, bigger attack surfaces, and novel kind of resource exposure as well. So now that we discussed about different kinds of AI threats and components, all these AI threats and components requires different kinds of or categories of solution. So we'll talk about AI security solution landscape and how, from my mental model perspective, it pans out presently. So as you can see, the green represents like data-oriented security solutions, which is like AI data security, AI data privacy. The gray represents like application-oriented security solutions, governance, risk and compliance, or observability, adversarial ML, and AI red teaming. I categorize LM security separately because it comes with its own threat vector, and as well, there's, I would say, it becoming more commonplace now to use LLMs. There needs to be more emphasis on it. Model security and ML supply chain security kind of model-oriented or traditionally machine learning model-oriented threats and secure against those threats. The solution secures against those threats. So from AI data security perspective, any solutions that kind of help in data loss prevention or kind of gives access to the integrity and availability of data. It could be traditional like security solutions by Palo Alto or Microsoft. A lot of cybersecurity companies have data security solutions for data loss preventions, which are now being used for AI perspective as well. This is more applicable during training time because at inference, often the data that it is exposed to is more of user queries or the context that has been added in terms in form of like RAG or additional files. Data privacy solutions. Data privacy solutions here kind of talks about how you could ensure the individual privacy of confidential data, or which consists of PI or personal identifying information. Some of the techniques that I mentioned here, like fully homomorphic encryption or confidential computing, kind of gives this protection if something goes wrong, would not leak or compromise individual information. AI governance and compliance, governance and observability. This comes under like GRC, but there's a different kinds of risk and policies involved with AI, and policies like GDPR, AI, NIST AI, RMF framework. All new AI policies are being kind of coming up and needs to be implemented in these tools. So they are like a twist to a traditional GRC tool. Model security kind of consists of scanning models, file formats. Some of the file formats are inherently insecure. We'll talk about that. And also model firewall. So what all things model should not be doing, and what kind of data it should not be exposed to, or what kind of queries it should not tackle, talks about that. LLM security is kind of solutions consist of LLM firewall, which whitelist different kinds of requests that are coming in, or guardrails, which ensures that the information that is being generated and both the user queries are being filtered for consistency and is doing the task it needs to do, and content safety, which is general to avoid misuse of LLM in day-to-day or in any capacity. Machine learning supply chain security solutions kind of tracks the provenance. This is a twist to software supply chain security solutions, where they talk about like provenance of libraries and tracking of different software applications. In machine learning models specifically, since it goes through a series of experimentation and a lot of training, there's a lot of different versions of models. And hence it needs to be tracked, and model signature is one of the aspects which needs to be implemented so that you ensure the model is not tampered with and it is what it claims it to be. Adversarial ML and AI reckoning solutions. These kind of solutions kind of are twist to pen testing of traditional application. So you put the machine learning model or the Gen AI application in situations where it is believed that it could do wrong, and check if it is working in a secure and safe manner or not. This is often done before deploying an application in production, and maybe done after the application is deployed in production as well, to ensure nothing has changed over the time. So AI red teaming, for example, needs to be done consistently because AI systems are unpredictable in nature. So you need to test them for outlier conditions and stuff. Now I'll talk about like machine learning model vulnerabilities. And these are vulnerabilities which have been reported in last few years. And I'll kind of explain it from a product manager's perspective. So like instead of just focusing on the vulnerability itself, how it could manifest itself in real world, essentially. So Pickle file, the document summarizer or Pickle attack. First of all, before going into the details, I want to talk about what is Pickle. Pickle is a machine learning model format which is inherently insecure and often used and was being used in a lot of open source repositories where machine learning models were being shared. So in this scenario, for example, there is a company called TechFlow. As a PM, you need to build a document summarizer feature to compete with Microsoft Copilot. And you're in a tight deadline, 6 weeks, to deliver this to a client, and which is a kind of risk in terms of building the whole feature, deploying it, testing it. And so doing these kinds of time sensitive nature, often security is put on backseat. So, and it is not uncommon essentially. So you as a PM ask the engineering team that we need to implement that. The data scientist gets the model from some open source community or repository in order to do it within the timeline. And the pre-trained model that they actually downloaded and started implementing comes with a malicious code, for example. And that malicious code would give remote code execution to the attacker, can run remote code execution and can give access to the resources that that it is exposed to, the model is exposed to. So if this model is deployed, which could be possible in production, it would give access to production systems, user data, and can lead to a lot more things compromised, like server compromise, customer document processes, customer document accesses, and network compromise as well. So the key technical factor that I want to highlight is that the pickle attack, for example, was so common, and even after, let me actually pull that. This is like a screenshot from the library page that pickle.py. And one key thing that they have mentioned is that they have highlighted the warning. The pickle module is not secure, only on pickled data you trust. So pickle itself is a file format, but which needs to be deserialized. And during this deserialization process, it by its feature executes some commands, and those commands, if compromised with, could lead to like attacker running any kind of code, or which could give access to servers or operating systems and anything essentially. So that's just one example of kind of machine learning supply chain attack, because here the data scientist who was who was trying to work within the timeline did access the unfortunately, or not even thinking deeply about it, used a model which was compromised and gave access to a lot of internal systems to that process. And till last few years, there were situations where, for example, on Hugging Face, you could actually change the user account. So, if, for example, if it's there's a model on Meta BERT model, for example, Meta as an author and BERT model is there. You could create a Facebook/BERT model, which would be a compromised version of model, and in urgency or during not paying detailed attention, that could lead to a lot more downstream impact on infrastructure and other applications that are using those models. So that's just one scenario. So as a PM, you need to ensure that security is focused on in this process. The second scenario is Kira's lambda layer attack. So Kira's lambda layer attacks essentially executes arbitrary Python code when the model loads. And in this case, for example, if you have a e-commerce recommendation system, you as a PM are working on e-commerce recommendation system, and you use Kira's model with lambda layers. These lambda layers are vulnerable to Python code on loading. So an attacker could actually use this vulnerability to get access to the user information, because often recommendation systems are based on persona that are being created, persona data. So this could lead to data exfiltration, like user ID, browsing history, clicking pattern, all these other informations could be disclosed. The reverse shell provided ongoing access to container infrastructure. So when these recommendation systems are running in production, it could give access to the containers within which it is running. It could give to unauthorized data transmission, which would be a violation of, for example, GDPR or CCPA, depending if you're in California or Europe. And could also compromise the user experience, because if an attacker could actually access the browsing data, it could also tamper the browsing data or click history to maliciously recommend products which may not be, which the application was not meant to be. So it has like broader implications in terms of like supply chain vulnerabilities, which is like third-party models, code dependencies. One key aspect or principle in both of these attacks that I'm explained is that model provenance, which is to verify the origin and integrity of model which is being deployed. This is often done like using AI bill of materials, which is like just as the name suggests, bill of material. Any machine learning model or an application would consist of all different inventories of uh, items that are part of that AI system, and who is the author of those systems, when was it created, what are the dependencies. So an AI bill of materials in this case, for example, could give the PM an understanding of what is the model that is being used and where it comes from to avoid this. And runtime security, which in these recommendation systems, if it is running real time interacting with user, it is important to do sandboxing like in a closed environment and monitor the model recommendation closely. This is often done by DevOps engineer or security engineers to check for if there's any unintended behavior or any warnings in the logs that that could come up. The third scenario is, as a PM, you are building a smart analytics dashboard and you want to run natural language queries, and you ask the ML engineering team to implement that. The data scientists use LangChain for code generation, which is a framework. LangChain kind of library that they use is obsolete and comes up with some vulnerability. And in this case, it's CVE 2023 365.8. What this vulnerability would do is it can circumvent the security fixes and generate codes with full application privileges. So in this case, what it could lead to is if an attacker has access to or comes to know that this library is being used in this application, they may want to infiltrate into the system and execute queries which would give access to kind of detailed business plans or a lot of important or confidential information. In this case, what the attacker would be doing, essentially social engineer some user account who has access to this dashboard. Like a feature is developed for some certain kind of users, essentially. So they try to re-engineer that, social engineer that to access to their account, start writing codes or queries which have hidden instructions to run on privileges, on higher privileges, essentially, and give like get system level access to it. So this has broader consequences in terms of it could lead to data breach, but also compliance violation, for example, SOC 2 violation if it is running on high privileges. And as what I want to highlight with this or all these attacks is that whenever a feature is being implemented, it's just not simple feature that is being implemented. There's a lot of factors in which this feature would be exposed to and can interact with a lot of different users. So security needs to be kind of forefront in any new feature development specifically for AI. So once I've talked about like different kinds of, I would say, machine learning model vulnerabilities, as the PM, what would be a security framework that you could follow? And I personally see security as a job of both product managers and engineering team. As a PM, you are responsible for the product and it comes with security implications as well. So you need to think about security at every phase of development lifecycle, during design, during development, during deployment, and monitoring. So what I mean by design is like when a feature or a product is being designed, you need to understand, list out the security requirements and what is the expected behavior from the system. During development processes, it's majorly kind of on engineering side, like to do QA testing and to regularly update libraries that are being used and kind of maintain the security requirements expected or published by the like company-wide security requirements and kind of compliance from industry perspective as well. Deployment and runtime protection in any process, development process or deployment process, there are a lot of subtasks or there's a lot of kind of, I would say, in deployment mechanisms, if you're using Kubernetes or so, there are different kinds of risk associated with it if you're using container-based deployment. So you as a PM need to be aware, at the same time also advocate that these security threats are being taken into consideration in deployment kind of process. Monitoring comes as like a runtime aspect, security or like continuous security. Essentially, what I mean by monitoring is that ML application, because of like unpredictable behavior or like non-deterministic nature, needs to be continuously monitored to see if they are behaving in within the boundaries which you as PM have defined, and also all the logs are being monitored to check for system requirements as well, or any alerts essentially. So I'm realizing we are close to, so I'll kind of skip these, but this kind of gives you a perspective of what could be different kinds of pre-development steps that you could follow: security requirement definition, architecture review, gate, threat modeling. Threat modeling essentially means that you need, this is majorly done by security teams, but AI-specific attack vectors that the application could come across are enlisted and then evaluated how the application would react and how it would kind of should behave, and also what is the impact, downstream impact or blast radius. Development process, dependency management, as I mentioned, a lot of open source libraries are being used, so they should be regularly updated for security reasons specifically, but also evaluated if the latest versions of different code libraries have been used. Code reviews kind of on the engineering front, but as a PM, you should be aware about the status and if it is being implemented regularly and kind of have access to the, oh, okay, no worries, I'll skip. Security testing, kind of explained in the code review as well that application level security needs to be tested. Adversarial input testing. Adversarial input testing is intentionally exposing the AI application to malicious situations within a confined environment, so that you could understand how it behaves and what needs to be changed in order for it to work properly. So you act as an attacker and to evaluate if it is working the way it should be, or if there's something going wrong. This is often done in order to avoid like aftermath once something is deployed. I talked about deployment and monitoring, essentially logging all the inputs and outputs that are coming in. This could be complex often because of privacy reasons. So there are different mechanisms to which you could log only the kind of relevant information and redact information that could be confidential or private. And all different kinds of security or cybersecurity tools have AI integrated to monitor these patterns and highlight those. So there are a lot of companies would use like CNAPP solutions to evaluate any kind of application that has been deployed. Incident response plan, I worked as a software engineer and I have gone through situations where we had to do rollback. So rollback procedure is equally important if something goes wrong. Let's say from dependency perspective, it's an old model. What is the rollback procedure and how can you ensure that it's done in diligent manner, as well as what went wrong is evaluated. So yeah, that as a PM you should be aware of, and you should also advocate for that. Rollback mechanisms are discussed, and procedures are discussed, that what are the key steps in that. So this kind of is the implementation checklist that, from a PM perspective, I would think if I'm building an AI product. A lot of this comes from like different cybersecurity principles, but at higher level, I would say that with AI security, it's just slightly different risk factors. So there's few more kind of resources and artifact that needs to be considered. On the right side, you can see like MITRE Atlas framework, which is based on MITRE ATT&CK framework, and it gives like it's kind of a framework to evaluate any kind of threat that a system could have. And I'll share the links of all the resources that you can actually go over and evaluate. So this is often done during like testing and threat modeling step, that you evaluate against different kinds of attack surfaces and processes. So yeah, now we are on the third part of our kind of my talk, agentic AI systems. So I'll be talking about like what is an agentic AI system and how it is different than traditional AI systems. Um, so here, what I mean by agentic AI system is that any application that leverages LLM to autonomously or semi-autonomously perform tasks, make decisions, and interact with user or other systems on behalf of the user. There are a few distinct characteristics of agentic systems, like autonomy and decision making. So they can make decisions on behalf of the users. Interaction with external systems. They may have access to different tools, calendar or meeting tools, or etc. They maintain some state and memory, and they help in kind of simplifying complex workflows. And at the end, they involve human interaction, but probably to evaluate, not during the decision-making process. How agentic AI systems are different than traditional AI systems? Um, One thing I kind of imagine is that agentic systems can do the task without you monitoring them, and can pursue the goal over time, making their own decisions. While for traditional AI systems, you are required to input specific details, and you get a kind of certain set of outputs. So for example, chatbot answering system or an image classifier are like traditional AI system. But for uh, agentic AI system, if you create an agent to do research on a certain topic, or if you build a competitor analysis agent, it would refer to different sources. You just give it a task to perform, and it would do all these series of steps of planning, action, then tool calling, and storing short-term memories, and then execute using large language models, essentially. So that's kind of how it is different. Now, talking about agentic AI system, it also comes with a series of threads. As I mentioned, every AI system comes with. In this case, a lot of these threads are because of the uh, access or the tools that it has access to, and also because agents can communicate with agents. So there's been common agentic AI pattern of using multi-agent systems, which means that your AI agent system is interacting with some other AI agent system. And if in this cycle, any of that AI agent system is compromised, or kind of has has been compromised, or kind of performs a task which is unintended, it can have a broader impact to other AI agents as well. So a few of the threats that I kind of highlighted here, and I refer to OWASP Top 10 Multi-Agent Threat Modeling Guide. So memory poisoning, which is similar to data poisoning, but in this case, attacker injects false or malicious data into AI agent's memory, corrupting its knowledge base or decision-making context. Um, it's similar to what it is in large language models as well. However, the impacts are different, and that's why this needs to be equally discussed. Tool misuse. Agents have access to external systems, email systems, APIs, and that could be manipulated. Privilege compromise. Weak permission management allows attackers to escalate privileges with agentic systems, essentially. Um, Resource overload, which means that attackers overload an agent's computational or service resources, causing denial of service. So this is equivalent to denial of service on large language model. Cascading hallucination attacks. Um, Agents are tricked into generating false outputs, which then trigger further erroneous actions, essentially. Um, Intentional breaking and goal manipulation. Since agents have so much autonomy, even a, a slight change in the goal or the task that it is given can lead to vastly different outcomes, and attackers can often compromise these autonomy to manipulate the task that the agent is performing. Deceptive behavior or misaligned behavior. Advanced agents may act deceptively, appearing aligned while covertly pursuing their own objectives. This is very different than the other large language model attacks because agents uh, could actually has more autonomy. So you need to keep uh, monitoring it at more minute level in order to see if it is working in the same function, same within the constraints and safety net that you defined. So it is more probable to do these kinds of action. Remote code executions, it's similar to a remote code execution attacks in other cases. Agent communication poisoning, this would be kind of on model context protocol level, or like the attack between the agent to agent communication. And rogue agents essentially means that an agent becomes malicious either through compromise or design and acts independently to subvert the system goals. So if it's a multi-agent architecture, a single agent could go rogue or have more access and can lead to bigger threats, essentially. I'll quickly go over model context protocol and then I'll open for questions and threats for it. So model context protocol is kind of client-server protocol architecture, but specifically for model-to-model communication. So it has a model client, it has a model server, and model host, and then the transport layer, which is the communication between these different clients and servers. And they often follow JSON, RPC kind of format. One point that I would want to highlight is that what was the need for a model context protocol? Before MCP, connecting AI applications, they were like AI applications to external system was very difficult. Like when you want to connect AI applications to different systems, there was not a single protocol or standard to have that communications. Each new AI model and each new tool or data source requires custom integration. So that if there's M models and data sources, it would result in M cross N problem. And this involved duplicating like development processes, inconsistent security and permissions, difficulty in maintaining and scaling as well. So Anthropic came with model context protocol, and they made it open source in November 2024. And I think Claude, I'm forgetting the exact model they came up with, MCP. Since MCP it's kind of a protocol and involves communication between model and different kinds of tools as well. So it comes with similar threads, but slightly different than agentic AI system. And I would want to highlight that model context protocol essentially it's slightly different concept than AI agent systems, which are like a system in itself. But however, this just talks about an open source protocol for communication between models and other tools. So a lot of these attack vectors are similar or subset of AI agent systems, but specifically from model context protocol. So prompt injection via data sources. Attacker can insert hidden instructions into upstream data like tickets or documentation, um, allowing manipulation of model output and data leakage or triggering unintended actions. Since there's often a lot of data sources which are linked to the model through MCP, hidden instructions or like prompt injection attacks could be performed through this as well. Okay. Token thefts and impersonation. OAuth tokens stored on MCP servers. So MCP servers would use OAuth, and if an attacker has access to those OAuth token, they can create their own instance and kind of imitate the MCP server and get access to kind of the communication that is happening. MCP expands the attack surface because it gives access to different kinds of tools and related vulnerabilities and chain of trust vulnerabilities. By compromising MCP or the system it pulls from, the attacker gains quiet but powerful foothold for data exfiltration, lateral movement, and model misuse. A lot of communication is based on trust between the different entities. And if that is compromised, it would lead to kind of access to data, the tools associated with it, and also model misuse. So after talking about MCP, I just wanted to quickly talk about like an actual AI attack that took place in I think January 2024, but was kind of found within a few months by Microsoft. And I'll quickly go over it and then I'll open for questions. So essentially what happened in this attack was there was a kind of a hacker organization called Storm 2139, and they exploited the misconfigured OpenAI endpoints, and they got access to the models. And what they did was they used attacker as they gave like access to these models to whoever wants, who were kind of bidding it. So it gave access to the computation, but also to the model itself. And they discovered these kind of exposed endpoint through missing authentication, and use these to generate like phishing emails and fake product reviews and stuff, but also give model as a service, hacked model as a service, I would say. Um, the key aspect here is that a lot of model-oriented attacks are not just attack on model as an artifact, but also the adjacent infrastructure where the model is being hosted. In this case, they were using API endpoints which were exposed and which led to this attack and compromise. But this would impact downstream both the models and the data. So in this case, it was fortunate that Microsoft detected that, revoked those API keys, notified the customers. The important aspect which has been implemented now is that rate logging and also logging and rate limiting. What rate limiting means is that whenever any kind of whenever you're using large language models, you could limit the number of queries that it is tackling within certain time frame to ensure that to avoid denial of service, and also ensure that if it is compromised, it would not damage beyond a certain would not damage beyond certain situation and certain requirements essentially. Microsoft also filed a lawsuit in East District of Virginia against these 10 unidentified John Does in December 2024. So this was like done very promptly, and this is a real world attack that happened on Microsoft. So this just explains that how AI AI-based threats are not just theoretical or academic, but also are going to become common now. So with that, these are kind of the resources that I use, and I'll share that. And I'll end my talk here. And I know we are on time, so if there's any questions that you want me to.
Thank you, Ameya. Thank you for such an incredible presentation. It's been very helpful, and there were quite a few comments in the chat with respect to how useful it's been. And thank you for agreeing to stay a few minutes to answer any questions anybody may have. If you're in Zoom, feel free to throw them in the chat or ask them live. If you're in LinkedIn, go ahead and put them in the chat, and I will pick them up there. I did see a comment from Scott, which is more of a comment, but very interesting. And he just said, the first part of your presentation maps out MLOps workflow where you could do everything nice and tight and right. And then as soon as you introduce agents, it pretty much blows everything up, it seems.
Yes, I mean, I'll just add to that comment that with agents, since a lot of it doesn't involve human interaction to that level, it has more access, and that's why the impact could be huge. Yes, it's no volume to security page then. So yeah, I saw a question by Jane. Are AI systems more vulnerable to security breaches than non-AI systems? Not exactly, but as an attacker, AI systems are a good target. If I am thinking from an attacker's perspective, often AI systems have access to confidential data, which is like an IP data of the organization. And they are more probable to have access to those. And that's why I would want to attack that system, which can give me more information, which could have more value than just general application. But I also want to highlight that in the present day situation, all systems are being kind of, you are pouring AI on everything essentially. So all systems are that you interact with would have AI in some or other aspect. An AI feature or like AI being the central theme of the system's functionality and business requirements essentially. So you cannot avoid AI-based threats until and unless you, even with all the applications that you're interacting with, until and unless you think about AI-based threats. So yeah, that's kind of my take on that.
Thank you. I guess we'll just leave it in case anybody has one more question. I know we're at time and a lot of people are jumping to their next meetings. Do we have any questions? Otherwise, we will wrap it up. Ameya, if people want to find you, is there somewhere they should go?
Yeah, you can find me on my LinkedIn. My first name Ameya and my last name Naik. I should share my LinkedIn actually. I'll share my LinkedIn in the chat. So I'm always happy to talk about security and privacy, and both in AI kind of perspective and in general. So I'm always excited to connect with new folks who are interested in the domain. Let me just pull up my LinkedIn. I'll put it in the chat.
Thank you so much. Thank you for an incredible talk. Thank you for everybody participating. Just to let everybody know, next week on the 18th, we have AI Product Manager's Guide to Feedback Loops with Hardeep who's a Senior Technical AI PM. And again, feel free to join our AI Product Management course and our AI Agents course to further your learning. We'd be very excited to have you in both. And Ameya, thank you for putting your LinkedIn link in the chat. Enjoy your Friday, everybody, and enjoy the weekend when it comes. Thank you so much again, Ameya. Appreciate you taking the time.
Yeah. Thank you, Ida, and have a good one, everyone. See ya. Bye.
This is Haritha, and I am Director of Automation at Eversana. And in my past, I have seen AI projects, generative AI projects, but there was always some level of discomfort when approaching with questions to the engineers and architects because just a lack of understanding of the technology. Well, I used to read online, learn some, do some self-learning, but it's hard to retain until you start putting something together on your own. And that's what the cohort helped us do is, introduce all the concepts, and we could go back and read more about it. Plus, applied immediately towards the end of the cohort. And that gave us much more confidence in talking to our engineers, our data people, and even trying to analyze a problem and see how a machine learning solution would fit in here. So huge shout out to Bijan and Kai for helping us in there. And I can personally vouch for this cohort because the kind of confidence that I have now before compared to what I had before cohort is like night and day. I understand the concepts more. I know what I should ask my engineer. So highly recommend it.